Hello everyone, N3FJZ here. This is a short video on some of the Arduino-based RF projects I've done over the years. And this one before you is a network scalar analyzer using the AD9850. So essentially what this is an RF generator, or RF function generator, or RF signal generator, and the main component here is the AD9850. These were those modules that were sold a bunch of years ago for $5 or $6 a piece. Let's see if I can get my light here on it. And what that does is it generates an RF signal sine wave under the control of the Arduino board itself, which I have right here. And the second part of the device, of course, is it's a small RF amplifier, and in these shielded boxes here is a logarithmic amplifier that will output a DC voltage based on the power inputted to it. Okay, and this is just a quick review. I'm not going to get into any real detail, but just want to show that this is what you can do with an Arduino and a low-cost module to generate an RF sine wave. I believe this is good up to 30 or 50 megahertz. I'm not exactly sure. Okay. The second project, which I use actually on my SSB rig, is it's essentially an SI5351, also an RF generator. This one generates a square wave. And this is the generator I have on my SSB rig that generates both the VFO and the BFO. And it, of course, is controlled by an Arduino, in this case a ATmega2560, which essentially is a Arduino Uno with a lot more RAM and programming space. So, and of course I have an LCD module from a Nokia phone. These modules are quite inexpensive, and it does everything I need to do for my rig. Okay, and another project I've done is a GPS synced real-time clock. And this one here uses the U-Blox Neo 6M GPS module. And this module is connected to a small GPS antenna I have sitting right outside my window, and this is the connector I connect to it. It goes down to the board. In this particular one, I'm using a miniature version of the Mega 2560, and these are quite small, and it provides all the functionality of an Uno, and again with a lot more RAM and program space. And of course the ultimate project I spent probably more of my time on is the SSB rig using that SI5351. And it started its life as a receiver, and I turned it into a transceiver. So those are some of the projects that I've done with the Arduino. You don't necessarily need the full Arduino board once you've designed your project. In this case, this is another real-time clock. And then as you can see here, it's just the ATmega chip itself, not on the one that would normally be on Arduino board. I have it here just on a breadboard by itself. And there's a few support components, crystal, a couple passives, and in this case to program it, I just built up a small RS-232 to TTL serial converter board that on a normal Arduino board you would connect a USB cable to the port. It would be this cable right here. But in this case, I just use a RS-232, and the converter board converts the RS-232 level signals, the plus and minus 15 volts, into a TTL. Okay, just want to give a quick video on that. And this is the real-time clock. In this particular one, I think I have basically two Arduinos, each one driving a different display, but they're both being fed from this one GPS module. And these components are not that expensive. I think the chip itself, I mean, you're talking $2 or $3 from eBay. The GPS module, you know, at worst is probably $15. At best, you can probably find them for $5 or $6. Same with the OLED displays. And of course, the old standby color display, which is a little slower in updating. So there you have it. (7-3) everyone. Keep building and never stop learning. And 3 FJZ. 7-3 everyone.